it's Wednesday, which means whether or not, the time of the week where Lauren asks us a very fancy question, a very scientific question. And let's be honest, Destiny, we usually guess.
We usually guess.
Yeah.
I feel like we were kind of across the board today.
I think we all guessed the same exact thing. So either we're going to look really dumb or really smart. Yeah.
Did you guess, though?
I feel like I heard you
I
say it before.
Okay, well, I want you guys to learn these things because I hope, because you and the viewers, pretty much everybody was on board with the same answer.
Good.
So I was very proud to see all of the answers.
But sometimes
that we
she
had
tricks
come in.
us.
She does.
Well, this wasn't too tricky. This was the true or false ones can I think be a little bit more tricky than the multiple choice.
Yeah.
But as you guys know, we do put these out on our social media, Twitter and Facebook, our social platforms, so that you as the viewers can answer as well. And obviously the question is what causes wind, and the choice was between Earth's rotation, pressure changes, incoming solar radiation, and gravity. So we had a couple people say solar radiation, or incoming solar radiation, which is basically just the sun's rays coming in, and the majority of people said pressure changes. And the Good Day Columbia crew, of course, we asked you guys as well, and everyone said pressure changes.
Okay.
So I'm
glad
proud
that no one guessed something else, because that person would have felt real. You know.
So this is not as exciting. We can drum roll, although I don't think we really need to. The answer, yes, is B, pressure changes. So I'm really proud of everybody for learning things. When we have a really, really, really tight pressure gradient, winds pick up a lot. Think about a hurricane or a nor'easter. When you're looking at the pressure within a hurricane or within a nor'easter or within an area of low pressure, these circles, the lines of equal pressure are very, very, very close together. So wind speeds pick up a lot. Very, very tight pressure gradient means a large change in pressure over a very short distance. That's going to pick up your winds. So winds, obviously, as we know, also blow from high to low pressure. Earth is trying to balance and go in equilibrium. So we always see everything go from high pressure toward low pressure.
I'll see the graphic sometimes when you'll have the L and the H for low and high pressure, and I know like whichever one of those, I know it's going to be cold coming up. Like, you know, you'll be like, oh, this pressure's coming in. That's how I kind of guessed. So
well, you guys did a fantastic job. Now, the other options that I gave, incoming solar radiation and the rotation of our Earth, kind of help with some aspects of wind. Remember when we talked about the westerlies?
Yes.
Those are created due to large pressure differences in our atmosphere created by incoming solar radiation.
Oh, okay.
But the large pressure differences, we have winds blowing from high to low, but when you add the Earth's rotation, they veer to the right in the northern hemisphere. That's that fancy word I used before, Coriolis force.
Oh, yeah.
Right, okay.
And then they veer to the left in the southern hemisphere. But typical wind that we see, really most wind, all wind, is done by pressure.
Pretty cool. Thanks for sharing that, Lauren.
welcome.
Well, stay with us, you guys. We got your morning sports update coming up after the break.